You let us know when you're comfortable.
If you want to start, maybe you can start and then we'll have more people join in.
Okay, all right. Great. So yes, thanks, Anjana. So good evening to everyone who has just joined. So if you guys have already attended our previous session, so we did a refresher on theoretical aspects of big data, types of data, acquiring data, and then how we could map it with real world applications. And we started with a couple of exercises on the core hands-on topic, which is basically pandas and things or operations, manipulations, which you could do with pandas. Let me go ahead and share my screen. Today would be a continuation of what we just saw. We'll just go through what we saw on that day, so that if some of you wouldn't have been, so if you weren't able to actually attend the last one, and then probably it will be a refresher for you also. Give me a second. Yes. Hope you're all able to see my screen now. And this is the default page which we had shared, which we created exclusively for this course. Let me put it again in the chat window so that it'll stay here. And if you guys didn't have the link of this, you could always go ahead and access the courses from here, the kits from here. All right. So the initial requirements were you need a Python, and you needed to install a Jupyter Notebook, and you need to have pandas installed as well. And these are the commands for installation. So once you have installed, you'll be able to start your Jupyter Notebook, and which will look like something like this. So I just started my Jupyter Notebook, which I have kept it already open. And let's just go through quickly on what we discussed the last day. So the first one which we did was the IO operations, which is basically the read and write operations in pandas. So when the pandas read data from the web is the first exercise we saw. And what we did here was there was a code snippet, we copied it, we did paste it in our Jupyter Notebook, and then ran it. A quick overview. Okay, I'll just run it again, and then we display the data frame. So we say that, okay, we read the data from the internet and then create a data frame out of that. That was our first task. The second task basically is once we do a read, we do a write. So for the write, we did have two commands, which is basically to convert it into an Excel and convert it into a CSV. So we did copy these, and then for the same data frame which we just created, we converted that into a CSV, and we found that the location where we want the CSV to be should be given as an absolute path. If we do not give that, it'll get settled in the current folder where this Jupyter Notebook is. So this is one, and then the second one is running that into converting that, writing that into an Excel. So these were the two things which we just saw that day. Now, if you guys are all set up, we'll just go and quickly cover the remaining 4 topics for the day. So the first topic, similar to the one with the read the pandas data frame, is basically read standard data. So it is load standard iris data in pandas. So this is the almost kind of a replication of the first topic, which is basically the read data. However, the reason why we are doing this is we'll proceed with the summary statistics and few other concepts based on this data frame. So it becomes easier for us to actually download it again, and it'll also be a refresher exercise for you guys as well. So as we see, similar to the first reading, we are just going to copy this code snippet and go back to the Jupyter Notebook, and in the cell paste it again, and I can have it as data itself as a new data frame. I'm renaming it to as data, and we are downloading a data set called as iris data, which is the standard data of a species identification of iris flower. So it is going to be, there are 3 different species in the iris genre, and based on some 4 characteristics, which is basically sepal length, petal length, and then sepal width, petal width. All these things, it will give us what category is the flower belonging to. Let me go ahead and run this cell. And then what we will have is a data frame here. And one important thing here to note is we find that the column has been here named as a contents. So this is like 5.1, 3.5, 1.4, 0.2, and iris etc., right? So these are actually the observations, which are basically the actual data. So when downloading from internet, we'll have to make sure only one thing, if the data already has a header or not. So currently in this case, this data doesn't have a header. It is exactly like a data. So to counter that, I'll have to give a parameter called header equal to none. All right. So when I give this and run it, the first row which we just saw as a column header gets accepted as a data, and then we have these columns. This could be renamed, but let's not take that today. We'll proceed on the summary statistics of how we can do some computations on this particular data set, and then proceed from there. I'll pass a moment here to have or any questions, if so any, and then proceed with the couple of other exercises here.
So any question, anybody can put it on the Q&A, and if not Q&A, you can also put it on chat. It's just that it's difficult to chat, find the questions, they just go lost in the chat. But if you have any questions, you can put it over here. I hope all of you installed the Jupyter Notebook and tried the exercise. I see Shibi raising a hand. Shibi, do you have a question? Can you put it on the chat? Because we are right in the beginning. I don't want to allow people talking right now. We can do it maybe in the end of or towards the end. If you have a question, you can put it here. Amrendra is asking, I have question on read from web, but will let you know at the end of the session. Okay.
Okay, great. Okay, Amrendra. Okay, if there isn't any, so I hope that you guys are on track as well. We could proceed with the concepts that are that we could discuss further. And to go ahead with, we just loaded a sample data set again, but this is kind of an data set which we could do manipulations on as a pandas data frame. I'm closing this, and then what we next have is a code snippet which states that summary statistics of a data frame. So when you go here and see, you'll see all so this is like typically this is the output which you'll see when running this particular code. And this summary statistics is kind of something called as a descriptive statistics, wherein you have a data frame and let's say you want to find some statistical data or aggregation, or what does this data mean? How many rows are there? What is the standard deviation of a particular column? What is the standard deviation of a particular row? And what is the mean, max? So all these basic aggregations could be generated or could be derived by analyzing a pandas data frame. That's what we are gonna do now. There are multiple rows here. This is just a snippet. We'll just go ahead and do a few of those. I'm opening this. Since this will be a lengthy one, I'm just going to open this particular code here. So I can click on it, open it in a new tab separately. So this way I'll have, this has multiple sections. This code snippet has multiple sections. I can run and see it individually. All right. So the first command which we'll see is something called as a describe. Describe basically gives you an entire overview of what this particular data frame does and what are different very key characteristics in it. I'll go ahead and copy this snippet and then go back to my pandas notebook and paste it. However, in this case, the data frame which we are going to analyze is called as data and not df. So I'll rename it as data and I'll call the describe method out of it. When I run it, we'll be able to see that it gives the summary statistics or numerical statistics for 4 columns. However, we have 5 columns, 0, 1, 2, 3, 4. This 4th column, the 5th column is basically a categorical variable. By category, it means that which species does it fall into. It's a text column and it's a categorical column. So it doesn't, it wouldn't be able to generate any numerical, let's say, aggregations for it. So for all the numerical columns, it will give us what is the count in each column. So we have 150 counts in each column, and each column wise, it will give a statistic on what is the mean and what is the standard deviation and what is the minimum value in that particular column correspondingly. Then it will also give us 4 different values, which is basically the quartiles. So let's say 0, and then what is the least value, and what is the 25th percentage value, what is the mid value, which is basically the median, and then what is the 75th percentile value, and what is the maximum value of that particular column. So all these data could be derived from the by running this only one single command. And this way we'll be able to find out that if there are any outliers, as in, like, let's say if you see that the min value is just 4.3 and the max value is just 7.9, and all the middle values, that is the mean and everything, are quite accommodated within this range. There are no any drastic differences between the lower limit and the upper limit. So we could also say that this data is kind of a balanced, normally distributed data, near normally distributed data, and we could proceed with an analysis on that. If by any chance in practical applications you come across a situation where you have the limits, that is basically the minimum value is very less and you have a maximum value which is like too much, then you'll have to figure out how to actually accommodate that. Because if you're not tackling that issue, then we won't represent the data really well. Whatever analysis we do, it won't be a good representation of the data that we just have. So yeah, I hope so far so good. You guys are clear.
Ganesh, I have a question here.
Yes.
So this data that you have put in a tabular form can also be, can we also put it in a graphical form of a normal distribution curve?
Yes, we can. We can. So that's a separate concept. So once you have this tabular data, you could plot it and choose that. Let's say if you have one particular column, you could choose and plot that one particular column and put in a normal distribution curve as well. We could do it.
Basically, you'll check one x-axis and one y, and then it will automatically plot, is it?
Yes. So x-axis will be typically the counts, right? When you go for one column, x-axis will be the counts and y-axis will be all the values of it. And when you plot it, and let's say you basically say that it is going to be what kind of a plot it is. Mostly if it is going to be a scatter plot, or if it is going to be a line graph, whatever it is. And you can have something called as a distribution plot. That is where you have all these different distributions, normal distribution, chi-square distributions. These are all there. for one particular column, you can individually put up a distribution plot and then see how it is actually being distributed.
Okay, great.
Yeah, and pandas has that functionality, some amount of plotting functionalities. But if we want to explore more on the plotting or different varieties or analysis in the plotting itself, we have separate libraries for that. Maybe something like as Matlab and Seaborn. So these are two different visualization libraries entirely devoted to visualization. So we could club pandas and then Matlab. And for analysis, we could use the pandas part. For all the graphs and visual analysis, we could use the Matlab part. Okay. I hope that answered your question, Anjana.
Yes, Ganesh.
Sure. Okay. So we shall move forward. We just saw the first command, which is basically describe, which gives you an entire description of the data frame. And then we go ahead and see the second command, which is basically, let's say we found whatever, we found the mean, we found the count. We could go ahead and see that there are two different scenarios here. You could do the computation either column wise, and you could do the computation either or row wise as well. If you do a column wise standard deviation, we can run and see. So for the same, I copy the code and I rename the df to be data, which is my data frame, and then call this std function, which is basically a standard deviation function, and x is equal to 0. So this gives me a column wise one, which is basically the one we see here, standard deviation 0, 1, 2, 3, 4, 4 columns, column wise standard deviation. We have it here. This is no big difference, but then we could also find it row wise. If we go ahead and see it row wise, we'll be having 150 observations, because as you see here in the data frame, it has 150 counts here. So we'll have 150 observations. I'm running it, and we'll see that it starts with 0 and ends with 149. So there are 150 observations, and row wise, it will give a standard deviation. So 5.1, 3.5, 1.4, 0.2. For all these 4, it will compute a standard deviation and then put it across in this particular row. So this is the second one. So we saw describe, which is an encapsulation of all this, and then this is the standard deviation. Then we could go ahead and do different other metrics, which is basically, yes. So mean, standard deviation. So okay, so earlier we just saw it here, we got it printed. We could do another thing as well. Let me put it in separate rows so that it becomes easier for interpretation. I add a new row, new cell, and paste it here. So here I'm finding the mean and then adding it as a separate column. So to just add it, you will have to call the data frame as data, and then this close brackets, and whatever column name you have to give, you can give that here. We are giving it as f mean, and then we are calling the mean function of it. All right. Now to check the data frame again, if this column has been added, we could just call the data frame, and we can see that this particular f underscore mean has been added as a new column here. So this mean is the row wise mean of these particular 4 columns. Let me give a pause here and see if you guys are comfortable so far in that.
Ganesh, there are some 2 questions. One is there any other GUI in there apart from Jupyter? I think you did say about Google.
Yes. So if we have to do it in local, we could do it in Jupyter Notebook, or even there are IDEs which you could use, as in like there are Spider, Eclipse, PyCharm, which has all these capabilities. The reason we are sticking with Jupyter is because in IDEs, you'll have to write it and then execute it, and it gets displayed only in the console at the down. But here you could interactively communicate with it. As and when you write one particular content in a cell and then run it, you'll get the output immediately. So it becomes easier for us to actually use it. That is one. And if you have to go with the cloud-based one, we could always have something called as, there are many open source things available. The most prominent one is Google Colab, that is provided by Google. It is kind of a Jupyter Notebook available there on the cloud. We could just sign in through our Gmail and then take it forward from there. So yeah, that is one.
Srilata has a question. When would the standard deviation row wise will be used generally? This is calculating the standard deviation across numeric value in the row, right?
Yes, right, Srilata. So this is typically like the example I just showed here, which is basically here. It computes standard deviation on row wise, and here it is based on column wise. The axis equal to 1, axis equal to 0 is basically column wise, and axis equal to 1 is basically row wise. And the only differentiation between using row-wise standard deviation and column-wise standard deviation is typically we would go with the column-wise standard deviation, because when we consider let's say a typical data analysis problem, right? We want to solve an outcome. There will be a problem, there will be an outcome. Let's say you have observation columns. Let's say you have 4 columns and you have a target column. What you will do is, based on these columns, understanding the characteristics or relation it has with the target column, we'll try to predict future values on the target column based on the input column. So that's how it works. So basically we'll go predominantly with the column wise only. This row wise is a capability where if you want to do some analysis and you want to, let's say, combine 2-3 columns together and have an analysis, or use a derived column. So in those cases, you could make use of this row wise computation as well. It depends solely on the application and the type of problem you're trying to solve. It depends on the data entirely, and how do you have to work with that. You could use both, but predominantly we go with column wise standard deviation. That's right.
Srilata, does that answer your question? You have further question you can ask. I realize you are there, you can speak.
Yeah, it did answer the question. So I just want to put it across, because we generally do column wise, but I guess, as you said, like across features, right? Trying to figure out some relationship between features and all, we would also do this standard wise. Yeah. Thank you, Ganesh.
No problem. Thanks. And we'll just see the min and max. So similar to what we just saw in the describe command, we could do the same thing here. We saw a standard deviation. We'll do a row wise min as well, and then kind of see it. We'll find that, okay, the row wise minimal value is 0.2 here, considering these 4 values. And similarly, you'll have it computed for all other rows. The same goes with the maximum value. So these are like basic aggregation commands, which we could actually use it. The reason we put together is because we just wanted to showcase these are many capabilities, and you add a new column, and to put together in a way that these manipulations could be put into place. That's why we just added these. Now let's go back and see if there are any more functionalities in this current code snippet which we could use. Yeah, so there is this interesting thing where instead of actually computing it in a way separately, we could actually put it in a more robust way, where basically that you're getting the aggregations in a straightforward command, in one command. This might be a bit confusing, but I'll just showcase it here, and then let's leave it off here. So this is exactly similar to what we just had in the describe command. All right, but the thing here is, if you see it in the one second, if you see it in the describe command here, we'll see that the data describe command does exactly the same thing. It has so many different metrics. We can derive the same thing by using something called as count mean, the same metrics which we could call and then get it out of it. This LOC is something called as an indexing. This is a method which basically is a default method in pandas. This LOC typically means that it's row wise sorry, it's column wise. You just see it in that particular index and then compute the entire thing out of it. This is a whole different thing. I guess we'll stop it here. We don't have to discuss it this session because it will become a lot more overwhelming then. So this section, it's like a basic manipulation on how we could derive what all details we could derive from the data. With this, we'll get over with the summary statistics that could be derived from a pandas data frame. So I'll stop it here, and then next we'll go through a couple of exercises. One is basically a basic sorting of possibility of what could be there in sorting, and the third is we'll have plots in data frames as well, which we could plot directly a data frame and choose what kind of chart we want to use. So these are two things here. We'll proceed with the sort of pandas data frame and then stop for some few questions and then go with the visualization part. Okay, so I open this new page, which basically states all the code for sorting a data frame. So let's say, to just put it in a way that it is being reused, we have just created something, a ready-made code snippet which has a sample data underneath itself here. So this is a sample on-the-go data frame. Let me explain how you create a data frame, if not by reading it somewhere. Okay, so I'm copying the code here, and see, since we already have something called as df, I'm putting it as let's say df1 maybe, and then we have a command here, something called as pd.dataframe, and then it encloses a dictionary. This curly braces is the dictionary, and inside this you have something called as a string, and then a colon, and then a list of values. All right, so this is how it is. And this pd.dataframe is a method that is inbuilt to pandas, which helps in creating a data frame. So any input that you give inside to the as input to this module, pd.dataframe method, it creates a data frame out of it. And typically you could derive data frame easily by a dictionary, because this dictionary will have all the components per se, which is basically you have the values here and the columns here. Let me go ahead and run it and then showcase it to you how it actually looks like. So we see that we created a dictionary, a key called TS, okay, and then values as an array of 40, 1, and 4. And then another key called A with the values inside of an array called 1, 5, 2. Similarly with D as an key and the values at 7, 8, 9. So when we give and run this, it generates the column name to be TS, and whatever array or list values we give inside it will be the rows, 4, 40, 1, and 4. Similar goes for A as a second column, and then 1, 5, 2 as a row, D as a third column, and 7, 8, 9 as a row. And there is another option here, which we say that, okay, we call or we set the index as list of ABC. We could also do without calling this index. If we don't call this index and then just run it, it'll come as 0, 1, 2. Makes no big difference though. So it doesn't make a big difference. You could actually set an index, or you don't have an index and then have a data frame as well. It doesn't make a big difference as when you do initial manipulations. When you do some advanced manipulations and you need to do some group by based on index or something like that, then this index might come in handy. So we just created a data frame on the go. And if you want to create a data frame similar to this, all you just have to do is you'll have to create a dictionary and then create a key, which basically has to be in as a string, either as a single quote within the single quote or a double quote. And the values could be in a list, which could be numerical, float, or it could be string as well. So yes, we just created a data frame on the go. We go ahead and see, we are going to see the functionality basically, which is basically a sort. And with pandas, there are two different things here. One is basically sort. Dot sort is the one function, and dot sort columns, sorry, sort values is another function. So sort values specifically is done for the values that is basically only the columns. For that particular column, let's say I want to sort this entire data frame by what column. The column that I want to sort with is TS column, and this axis equal to 0 specifies that it is column wise sorting. And for this ascending is an inbuilt parameter. If I give it this to true, it will sort that particular column based on in the ascending order. Else it will sort it on the, if I give it as false, it will sort it in the descending order. And then there is another parameter called in place equal to true. If we give it as in place equal to true, this particular column entire data frame gets rearranged. So as in, like, based on that particular sorting, the data frame gets rearranged. Then there are different kinds of sort. We have something called as quick sort. We have something called as merge sort. So there are different kinds of sort. It entirely impacts only when you have a large data set or a small data set. Depending on, let's say you are going to process 100,000 observations or 100,000 rows, and you want to choose an optimal sort in that case. So if you choose a sort that's going to have a higher degree of complexity, then it will take a lot of time to do the sorting. That is the only difference it makes. And let me go ahead and run it. Let's say here at TS. Just a second. Oh, okay. I'm sorry. So it is basically a data frame 1. We just renamed it. So data frame 1, sort values. All right. And then I'll just give again that. Okay. Print data frame 1. We can see that we just chose an ascending sort. Okay. And the values are 41 and 4, where 41 and 4, and it has sorted it on the ascending order, basically in 1, 4, 40. That's what we needed. And we gave it as in place equal to true. So correspondingly, when we give in place equal to true, the other columns also get the values get replaced accordingly. So here we see that 1 is the first number that has to come, and then correspondingly the corresponding row entirely comes into place here if we give in place equal to true. If we give it as false, then it doesn't come. So
Ganesh, so I have a question here. When you sorted, it is only the sort has only happened on the first column, correct?
yes, true. That's because we are calling the sort values, and we are giving a column here. By is
Okay. Sorry,
yeah.
missed out.
So yeah. We just have to figure out on which column we'll have to sort it. So we are giving it as TS here. So based on that column, it is sorting the entire data frame. We could also try something different. Let's say, okay. So here instead of TS, I can copy it and then do it on a different column. And then let's see, if it's going to be A, and then run it. And then see that, okay, here the initial it was 41. Okay, with A it's already sorted, so it doesn't make any big difference. It again comes back to the same data frame. It was 152 previously, and with this ascending equal to true and in place equal to true, it comes as 125. If we set it up ascending equal to false and then run it, it will give me the sorting in the descending order, and the corresponding data will the corresponding row will be filled accordingly by other columns as well. And so this is sort values, and data frame also has a function called sort, which basically applies on the entire data frame. So it will sort it entirely on the whole data frame, whatever the minimum value it is for each column. Whatever the minimum value it is, it will sort it and then give you a row. And most of the time, the direct sort is kind of are not more efficient, because you would want to know the characteristics based on each column, because that's where we'll figure out what the range is, and then proceed with what kind of pre-processing that we need to do for running a machine learning model, so or a data science model. So mostly we'll resort to sort values because we'll have to have the observation sorted by the entire based on one particular column and then get some insights out of it. So this is another one. We'll stop it for a while and see if there are any more questions. We'll go ahead with the plot feature of it after this.
There is a question, how to deal with categorical data to perform statistical or mathematical operation?
Okay, so by statistical or mathematical operation, let's say if you want to get something like this aggregates, which we just saw, okay, so let's say mean, max, these aggregates. So there is an option to include categorical variables. So we'll the pandas has an inbuilt option called, I guess, include all. So there is an option for that, which will take into account of the categorical variables as well. But then if you take into categorical variables, the metrics which you will get is will be something entirely different. And typically when it comes to categorical variables, we do not take into account of these statistical metrics. We'll have we'll take them into account of something called as levels, which is basically gives you a count of let's say you have one categorical variable here, as in like Iris, Setosa, Virginia. Let's keep it 2, okay? And these are 2 different levels, which is basically 2 different categories. And you can have once you set a particular variable or a particular column to be a categorical column, you could run something called as levels on that particular column and then figure out how many different categories are already available. And based on that, you will be able to see the frequency of that. So let's say if I run something like some command like sort values on this particular column, considering, we'll find out that Iris Setosa has some out of this 159, there is 60%, which is basically let's say 70 to 80 of this particular column contents is Iris Setosa, and the remaining is Iris Virginia. So we'll know that how much of those categories is present in that particular column, and that indirectly responds to the fact that if this particular data is a balanced one or a non-balanced one. I guess I did a bit more answering, so I suppose it answered the question. If we have 2 classes which are like a minor class and a major class, minor class is one which has a very less frequency, only 10 observations, let's say, and a major class which has 90 observations. Let's consider something as an a problem where you have to find identify if particular okay, a particular let's say cancer prediction or something like that. You have so many characteristics there, and then ultimately at the end you want to find out if these characteristics are present based on the columns. You term that there is a probability of getting cancer, or you fall it into a category that okay, this is cancerous, something like that. So if you have a very minor and major difference in the data set, that is only few classes which specify that you have a probability of getting cancer, and few classes which says that if you have these characteristics, you don't have a probability of getting cancer. But the entire goal should be on what you are trying to solve, what you are trying to predict. If you are trying to predict if they will more likely get cancer, that means that you need to have adequate amount of data to capture the patterns contributing that particular cancer class. So I guess this might be a little bit too much. If I'm not clear, I can reiterate as well. Yes. So can we typecast categorical data into integer instead of labels? We could, but the thing is, it typically works in states where the majority industry standards we go for is, let's say, encoding methods, which are like one-hot encoding. There are different encoding methods as well. So based on the number of categorical data for a column we have, we'll have to choose the appropriate encoding model. And even when you convert that into an encoding model, you could still convert it into an integer, but then it will have some consequences on your model. We could do it. There is obviously a way which we could convert a categorical variable into an integer variable, but the impact of that conversion in your in your problem or data science solution is something that is peculiar to each and every data set. But the industrial standard is typically an encoding method where you convert them into an order of 0, 1, 2, something like that, and convert that into categories. Okay. If there aren't any questions, we'll proceed with the part of visualization, which is basically data frame plots. It's a straightforward one. There are multiple options available even here. If we want to do it separately on column wise, that is also possible. And there are other plotting libraries in Python specifically providing sophisticated capabilities in plotting and visualization, like Anjana asked in the initial timing about the distribution plots and stuff. So that could be done in pandas, but it will be a lot better if we do through a visualization library, which is basically Matplotlib or Seaborn. These are more common ones that are prevalent here. So we'll generate some random data like we did on the last time, and then let's say this is going to be my df2, and I create a data frame calling this pd.dataframe function, and I create a dictionary with values. So it has game 1, game 2 columns, game 3 columns, and an index to be team A, team B, team C. So 3 teams, 3 games, and their scores. And to view it, I just type here. So you have game 1, game 2, game 3, and team A, team B, team C. So these were the scores of them. Then if I have to just give a plot of it, so typically this will be a bar plot, right? So it's a one-on-one plot, so it's a bar plot. If we go ahead and see it, we could see that we could just plot it, and then okay. All right, so this plot means that we'll have to have another library that is being installed, which is basically matplotlib. So let's say, okay, I'll import matplotlib as import matplotlib. I'm not sure if matplotlib is already installed in my machine. If not, we could go ahead and try installing it as well. So I'll run this. So okay, no module. So that means that I'll have to run this matplotlib installation again. So I'll run cmd, and typically how we install pandas, we could go ahead and install matplotlib as well. Matplotlib. Okay, and I just stated that, okay, installing collector packages, cycler. All right. So one thing to notice, we worked on the Jupyter Notebook and we installed something. So how do we actually make it? It doesn't directly get connected. You'll have to actually restart the notebook to make that installation in place. So there are 2 ways I could do it. I could close this session here in the command prompt and then reopen the Jupyter Notebook, or without doing that, I could go to the kernel here. There is a kernel tab here on the running Jupyter Notebook. Click on it and say restart. Okay. So if we restart it, all the data that are previously stored will get cleared. You'll have to run the notebook from the start. But all data that you already have, that is the package that you just installed on the runtime, will be available. So now when we run this import matplotlib as PLT, it works. It states that it doesn't give me an error. So we just installed it on the go while working on the Jupyter Notebook. And to reiterate or to make it involved in the session, we clicked on kernel and then restart. It will just restart the Python kernel and take into account of whatever we just installed newly. Now I'm creating a new notebook. Okay. So I'll have to import pandas again from the start because we are starting with something new. So I'll import pandas as PD again. This module get imported, and then I'm creating a data frame. Now I'll see what the data frame is and then go ahead and plot it. It is basically df2.plot. Okay. Now, if we go ahead and plot it, we'll see that a bar graph, which states for team A, team B, team C, which is basically the index and the corresponding values of it. So team A, game 1 in the legend we see. So game 1 is basically 4, and you have it 4, and game 2, game 3. So similarly, for you could extend it to any number of rows and any number of columns, and you could still get this graph. There are different kinds of plots that are available in pandas, but it has certain limitations. So for the kind of data that you have, you could only generate plots based on what the data you have. So you cannot simply have this and generate something kind of a density plot. It won't work. So based on what data you have, you could visualize it in a particular graph as well. So this is a preliminary touch-based thing on all functionalities available. So this df2.plot is native only to the pandas. We could extend it more by making use of this Matlab library. And in the page snippet page that I had shared, there are capabilities for that, which provides control on the figure size and what are different plots that could be available. So it is there, but I'm going to leave it here to just keep it in pandas itself and not include Matlab. So we just saw this visualization as well. We could have some more questions if
so Amarendra, I think in the beginning said I have a question, I'll ask it toward the end. So we are left with very little time. So Amarendra, if you want to ask that question, since it's Friday evening, we would like to also Ganesh go away from Python for a bit. So yeah.
Thank you, Ganesh. And Ganesh, while reading the data from the web, I'm getting this problem. Like most of the time, I'm getting this forbidden error because I know websites are not allowing. But see, if I'm getting from Kaggle or from any other sources, it is working. But directly, if I go and check, let's say from India AI data or from gov.ai, from there, how I'll do that? Every time getting error, could you please show demonstrate one real-time one? Go to web and
so typically there is one way you could do it. So typically all these public data sets, right, they keep changing their APIs frequently, and one thing which could be done is they'll have a specific API section. So you cannot let's say you want to download a CSV, and if it is already in GitHub, what you could do is you could just say click on that particular CSV, get the URL out of it, of that particular repo, and then call a curl or something, it'll automatically download, right? That's how it works. But then with this public data sets, it's not always the case. Some of them do have something called as an API concept, where they'll give you, they'll display a separate link, they'll expose a separate link for that particular data set. We'll have to copy that and then call it separately. And not everyone has this ability to just send the data to you, because they do have some restrictions, and many of the open data set hub have this forbidden error, mostly because they have a specific pattern to follow, and it is unique to each and every library, open source repository. Let's say it is UCI, open data sets, each have their own API key. Previously, it wasn't like this. Previously, you could just give like what you are actually telling. You could just call the link to that particular file in the URL and then run it. It will automatically download the file. But for security purposes and to prevent DDoS attacks, they have changed it in a way that you'll have to follow that particular structure. So it varies from each and every site. And they have something called as an API. You'll have to go through that API and then send the request accordingly. It
So
should work.
thank you. So one supplement question on this. So while doing in real-time data analysis, whether the business will provide the URLs which is available or not restricted, or how it will be?
There are two ways. It actually works on how the use case is to be solved. And typically, to avoid this network error and all those stuff, what we would do is we'll resort to two things. One, we'll have all the data in the cloud, and with cloud providers as in like GCP, Azure, AWS, and the data rests in the cloud. We typically, and for an enterprise account, we won't have a downtime at all, and will not face much of this network issue. If the business is okay with that, they could have it in their cloud account and then give us permission, let's say login permissions for us to access that. And it works. Majority of the way, it works in the cloud that way. Or we could have the data imported to our end, save it in our database or save it in our cloud database and then use it. So it's either on the client side or here. And with real time, it actually doesn't work that we'll have to hit a different website, get the data, and then work on it. They'll have it stored somewhere.
Okay. And one more question, like you have installed like that Matlab.
Yeah.
Jupyter Notebook, right? Instead of in CMD.
No. I installed it in Jupyter. In CMD only. So you could see it here. So I did pip install Matlab here only. And after installation, you will have to import the module, right? So I just imported it here. You could install through through Jupyter Notebook as well.
Yeah.
If you want to, let's say, run Matlab here, okay. But the thing is, if you have to run command line parameters, you will have to add an exclamation at the start. So then it will understand that this is not a command that runs in the Jupyter. It has to have the characteristics of a command line. So this exclamation is the one that defines that this is a command line command. So you could do this or you could do that. But it is always better to do it in the command line because this adds another layer and it might take some time because it will go through Jupyter and then process is as a command line operation and then get the result out of it. Rather, it is always better to run directly on the command line. It makes it fast because it is native to that.
Thank you. And one more question, sorry to disturb you. So while working in real-time data analysis, like what are the major functions like we have to deal with pandas, related to pandas?
Okay, so with pandas, predominantly, these are the basic functions here. We'll obviously have describe to identify how the data set is, but then we'll for further drill down analysis, we'll go into analysis of individual functions. Let's say if there are 2-3 functions which are more related, we'll see if there is a pattern and we could group by certain values or certain rows, certain columns, and then get a derived a column out of it or a row out of it, and then proceed with that. And this is one, and majority of things come into place where for categorical data, we'll have to deal with something called as class imbalance. The one just I saw about. Majority of the real world cases will be an imbalanced data. We'll have to figure out how to actually counter that and then make the data as a better representation for the problem that we are trying to solve. Because if we don't tackle that and then try to solve it, it will work on the test data. But when you have some more unseen data, that is new data that comes in, it will obviously fail because we haven't encountered all possibilities of errors in the trained data. We do with only preliminary analysis and then proceed with the prediction part. And then when a new data comes, it fails. So we'll have to take into account of this class imbalance, which is predominantly 95% or even 97% of the time. That's how it works in real time.
Thank you.
And another functions we'll do is we'll do basic functions like filter. We'll have to need only subset of the data. We'll get subset. So these are some advanced data wrangling functions that are available. We'll use that.
Right. Any last minute questions? I think we have covered basically all the aspects which are important for the assessment perspective. That is what we wanted to cover, because otherwise it will get, there is no end to this Python. So, and hence we are trying to just solve for one thing at a time right now. So you have any questions related to so far what has been covered? Actually, I asked Ganesh to go through the acquiring data course, and I said only on the Python part people have not practiced, and that's one portion where there's not much in the course also. So if he can cover that. So yeah, anybody has any questions? And also they have, so OpenViewer is really a sweet partner with us on this. So they've created one dedicated area for acquiring data, which the link you guys have. There is a portion where you can even ask your query if you have a query.
Yeah, to provide more emphasis on that, if you log in, you'll see something called as, without login, you could just reply. It'll ask you to sign up, but it is always better to sign up or sign in, and you'll have a chat feature accessible as well. So that is a private chat that is also available, and this is the kind of a forum one where if you post it, people all over the world could see it as well, and then make use of some issue that you are facing. So you can use both these and reach out to us.
Okay, so if there are no questions, then we are on time. I mean, and we will just, close it. And thank you so much, Ganesh. I mean, thank you. I told him not to make it overwhelming, and I wanted him to just stick to the, to the basic thing that would be important from the exam perspective.
Yeah, true, Anjana. So that's the reason we thought, okay, we'll keep it very simple. So it might be too simplistic, but anyways.
And so thank you, everybody. Thank you for joining us. And I hope all of you are able to take the exam after this. And this whole thing helps you in, because there are no coding actually in the exam. It basically asks you for functions in the, there's no coding that you have to do. So it will be very helpful in passing whatever 3 or 4 questions which come in this area. Thank you, Ganesh. Thank you, everyone. Good evening. Bye-bye.
Yeah, thank you. Thanks, Anjana. Happy learning.
Thank you, Anjana. Thank you, everyone. Bye-bye.
Oh, I didn't realize Smita was there. Huh? She never came online.
I was just listening in because Ganesh and you kind of had the whole session under control. But just to conclude, it's always a pleasure to work with FSP and with you, Anjana, Smita, the entire team. It's been a lovely experience, and I hope all of you enjoyed Ganesh's session as well. So as Ganesh said, please come back to this page if you have any questions. We're here to support you, and maybe if you'd like a next level, a step up, we have resources for that as well in terms of a one-click solution kit. So, yeah, with that, happy Friday. Thank you so much, Anjana.
Thank you, Smita. Thank you for supporting. Thank you, everybody.
Thank you, everyone.
Thank you.
Bye-bye.
Thank you, Ganesh.
Thank you,
you.
everyone. Goodbye.